I am KV Mahalakshmi, working as an assistant professor in BV Raju Institute of Technology, Narsapur, Hyderabad. So today we are going to see a topic on search algorithm in Introduction to Artificial Intelligence. So first, search algorithm. So what is search algorithm? So before that, we are going to simple introduction about artificial intelligence. So artificial intelligence means the name itself, it is going to define. So artificial intelligence. So artificial, any type of artificial thing that is going to use the intelligence like human intelligence that work on its own like human. So that is called artificial intelligence. Simply we can say it is artificial plus intelligence. So any objects or anything that is going to use a human intelligence, that is going to work on its own like a human. So that is called what? Artificial intelligence. So first thing, search algorithm. So artificial intelligence search algorithm is mainly used to find the solution, solutions. What is the solution? Suppose you are giving any problem. For that problem, you have to start that problem and you have to find the solution. That finding the solution, that is called our goal. So suppose if you are playing a football game, so from this, what you are going to do first, you have to take the ball and you have to pass the balls to others, and you have to, what is the final? You have to put the goal. So that is our goal. That is our final state. So putting goal is a final state. So start state is you have to take the beginning. You have to start the game. So that is our start. So here search algorithm consists of three things. One is state space. Another one is start state. Another one is goal state. State space. State space is nothing but it is a possible of all the solutions. Simply we can set of all possible states, set of all possible solutions. Suppose if you are in a football ground, so this is our goal post. So what we are going to do here, we are going to, these are all the players, for example. So what here we are having the ball. So what is this? This whole ground is said to be state space. Suppose this person is having the ball. So this is our start state. He have to start the game, and he have to pass it to the nearer players in order to reach the goal. So this is our goal state. So putting goal is a goal state. So the complete ground consists of all the possible state or possible solution is said to be state space. Next, who is going to start the game? From where you are going to start the game? That is called what? Start state. So final decision, final destination, that is called goal state. So there is a type of search algorithm. So what are the types of search algorithm? Uninformed search, informed search. By the name itself, we can understood what is uninformed and informed. Uninformed means it does not give any additional information how to pass to the other successor. Successor means nearby state. So previous example, when we take the football game, so nearby players will be there. The own set of players, own team of players, near set of players will be there. Near successor, that means that is called successors. So the successors, to go to the successor from the start state to reach the next successor, we doesn't have any additional information to reach a successor or to reach the goal state. Simply what you have to do, you have to start from the start state, we have to reach the goal. So one is mainly you have to start from one state and you have to reach the goal. Whether here we are checking whether we have reached the goal state or not, whether or else we can say it as whether the last state we have reached, that is a goal state or non-goal state. We are going to find that state. So that is called uninformed search. We don't have any additional information to pass the information. To pass the information or to reach the goal state. Simply we are going to find whether it is a goal state or not. That's it. So informed search. So informed search means there will be a additional information will be there. So how to move to the next successor. So what is maybe the optimal path to reach the next successor? What are the procedure? What are the additional calculation we can take to move from this beginning state to next state, or from the current state to the next state? So there will be some calculation, there will be some additional information used on some functions. We will find out that one. So by giving any additional information, that will be comes under informed search. Uninformed search is of three types: depth first search, breadth first search, uniform cause search. Informed search is of greedy search, A star, graph search. These comes under informed search. So today we are going to see about depth first search. So uninformed search. So in uninformed search, by the name itself we can say it does not have any other information. Other information doesn't have any information. So because of that we are saying it, this is a blind search. So blind means there will be no information. Only what is that algorithm only generate the successor and differentiate between the goal and non-goal state. So previously I have told. So what is that? It will find whether what are the neighbor successor. That is neighbor successor means neighbor nodes or neighbor state. What is it? So it will generate all the possible state. Then after that, what we are going to differentiate whether we have reached the goal or not a goal state. We are going to find whether goal state or not goal state. So that's it. So blind only we have to start, we have to end. So end, whether the ended state is a goal state or not, that we are going to find out. So because of that, we are telling that this search algorithm is called as a blind search. So here we are going to see about depth first search algorithm. So depth first search, we are telling us DFS. So depth first search. So by the name of the depth first search or DFS, we are able to identify. We are able to understand that it will traverse, or traverse means we are going to find out, or we are going to travel, find out, or travel, or we can say it is move, whatever name. So traversing means we are moving from the start state, we are moving in depth wise. Suppose this is our start state, these are all the successor states. So suppose like this, the graph is like this, this graph is like this. So what are you going to do? First, you are going to find you are going to move from the start state. This is our start state. Suppose we can say this is our goal state. So we have to find the goal state from the start state. Okay. So from the start state means how we can move. So in this depth first search, we are moving in the depth wise. Once we reach the complete depth, then if it doesn't find any goal state, then it will move to the previous state, and it will move to the previous state, again it will move to the previous state, again it will move to the previous state, like this. So if again it doesn't find any goal node, then it will move to the next subtree, that is right subtree, and it will start to find the goal state. So that is called what? Depth first search. Simply it will start from the start state, go from the left, it will go in the depth wise until up to the last leaf node of the particular depth. Then even though it doesn't find any goal node in the depth, then it will backtrack to the previous state. Then if it does not able to find in one complete subtree, then it will move to the another subtree, then it will start the same procedure until reach the goal state. So depth first search is, it will follow a depth first search, and if it doesn't find any goal state, it will backtrack to the previous state. If again it will move to the another subtree, then it will do the search until reach the goal state. Simple. Next, it follows one data structure. So what is the data structure here? It is going to use a stack. So stack structure will be like this. This is called stack. Stack can perform two actions. One is push, another one is pop. Push is similar to insert. By the name itself, we can understand push. Pushing means you are going to insert. So pop is nothing but we are going to delete it. So push and pop. Push is we are going to push a new element. Pop is nothing but we are going to delete from that stack. So push and pop, both operation will be done in the top of the stack. So here this is the top of the stack. So this pointer reference is the top of the stack. So push. Suppose if I want to insert any element, this will be done here. If I want to delete any element, A will be deleted. So insertion and deletion will be done in the top of the stack. So first in, that's why we are saying is, that is, we can say it as first in, first out. Whichever is the first, it will enter, that will goes to the first. So we can say it as in the last element inserted in the top of the stack will be deleted at the first. So last element entered into the stack will be deleted first. So that's why we are telling it's last in, first out strategy. So we are going to push the element and we are going to pop the element. Whatever may be the option, push or pop, that will be done in the top of the stack. Top of the stack is always pointed to the first thing. So last element which is pushed into the stack, that will be deleted first in order to insert another element. So this is the working of stack data structure. So here what we're going to, here we are going to use the DFS search using the stack data structure. So we have to start from the start state, we have to search up to the depth wise until we are going to reach the goal state by using the stack data structure. We can clearly understand by seeing the example. In step 1, we are going to see how we are going to start this from the start state and we are going to see the goal state. So first thing is, this is a given tree. So for this given tree, we are going to find the path by using DFS search algorithm. So DFS search algorithm. So what is going to do? First, it will start from the start state. So for example, we are taking here, we are going to take this G as a goal state. Okay, G as a goal state, A is a start. So first we are going to insert, first we are going to start from the start state A. So that A should be put it in the top of the stack, A. So initially it will contains only one node A. So what is that? A. Next, we are going to find, in second step, we are going to find the successor of A. From A, where we can go, either we can go by B, either we can go by C. So once what you have to do, in stack, if we have taken A, that A should be removed. In place of A, we have to place B and A, we have to insert B and C. So that's why we have taken B and C, that is here. So first we have to start from the start state A. From that, where we can move either B and C. So these are the two successors or two children of A. So next, B and C. Next. So previously from A we have traveled from B and C. So this algorithm follows depth wise search. So what you have to do here, we are going to expand the B node. We are not going to consider the C, we are going to consider the B. So A, from A we have seen B. Okay, because in depth wise. So this depth. Okay, by this depth you are going to find the search. So B. So next node to be expanded is B. From B, what are the successor we are having? Either it is D or E. So that's why we are taken this one. D, E, then C. D, E and C. So okay. So D, E, C. Already A is there. Then we have moved from B to B and C. Then from what is it, instead of B, what you have taken? We have taken D, E, C. So this is the procedure. Next thing is we are going to find we have to each and every step. Don't forget that each and every step you have to check whether we have reached a goal state or not. What is our goal state? G. Whether we have reached a G? No. So next thing we are going to expand is D. We should not expand E. E is already a glyph node. Okay. Next is we are going to expand D. So what is that? A, B, C, then D, E, C. Instead of D, instead of B, A, B, C, you have, instead of B, instead of D, we are going to take C, F, E, C. So C, next one is next node to be visited. What is the top of the stack here? C. So C we have to expand. Next one is we are going to expand the C. Next, after expanding C, so what we are going to get after expanding C? We are going to get G. So what is A, B, C, next D, E, C, C, F, E, C, next G, F, E, C. Okay, next one is from this procedure, next one is in the depth wise, next node to be visited or next node in the top of the stack is G. So we have to check whether the top of the stack is a goal state or not. G is a goal state, we have to stop it. So we have reached a goal, so we have to stop the search. So how we can understand? First we have started with A. We are going to expand. This is a start state. This is a start state. So we are going to expand A. In next we have find out B, C. Next top of the stack is which node we are having? B. So we are going to expand B. So we get E, D, E. Then already C is there. We have to keep that one. Next one is top of the stack is D. Then you have to expand D. Then C, F, E, C. Next, what is the top of the stack? C. So C you have to take, then you have to put G, F, E, C. Next node to be in the top of the stack is G. So G is our goal node. So we have reached the goal. So how we have reached the goal? A, B, D, C, G. So this is the path we have find out to reach the goal G from the start state A. So what is the depth first search? Depth first search is we have to start the search from the depth wise, from the start node to reach the goal node. Here only this is called only uninformed search. So there is no any additional information will not be there in the search. Only thing is we are going to find whether we have reached a goal or not a goal state. So for that, what is the procedure we are following? Depth wise. Depth wise, we are going to follow until reach a goal state. If it is not reached the goal state in one subtree, it will backtrack to the previous state and move to the next subtree, then find the goal state. So this is a simple rule. So to follow that one, we are using stack data structure. Stack data structure is last which data or which state comes into the last into the stack will move out from the stack first. So that's why we are telling us last in first out. So by using that stack data structure to find the depth first search, we have find out we have used some example to find out the path from A to G.
Like, share and subscribe. Hit the bell icon for more updates.